Alright, our topic for today is going to be half-life. Before we go to the definition, I would wish to take you through some interaction here. With radioactive nuclide, it is very impossible to know exactly how when one atom will decay, because it happens at random. But now when we have a large enough number of atoms, then decay will happen. Now for us to know the number or how much time it takes for a number of atoms to decay, that's when we use half-life. Then now let's know what half-life is. We should look at the definition first. So by definition, half-life is the time taken for a radioactive element to decay to half its original. It is measured in seconds, minutes, hours, days, weeks, months, and years. Half-life is not affected by physical factors like temperature and pressure. It's also different for different radioactive nuclides. Now, if N0 is the original value of a radioactive element and Nt is the mass of a radioactive element at any time t, then this is the formula that we use. We use N0 over Nt, which is equal to powered by T divided by T a half. T a half is the half-life of the radioactive element. We also have another alternative formula of how we can deal with finding the half-life of a nuclide. Now this is the alternative. We have the mass, number of halves, and then time. At the original number of mass, we have 0 halves and 0 time taken. So first half we shall have N0 over 2, and then the half will be 1, and then the T will be multiplied by half-life. The second will be N0 over 4, then the half will be second, and then 2 multiplied by the half-life. The third will be N0 over 8, then the half will be the third, and then 3 is multiplied by half-life. And now it continues that way till when you reach the last point of your calculation. Now let's look at one example. A radioactive element of mass 8 grams has half-life of 8 days. Then they want us to find the mass of the element after 24 days, mass of the decay after 24 days. And then the solution is, from the question above, N0 is 8 grams and T is 24 days. Half-life is 8 days. Nt is the one we are looking for. Now from the formula, N0 over Nt is equal to powered by T over half-life. Now the original is 8 divided by Nt, which is equal to powered by 24 divided by 8. 24 divided by 8 is equal to 3, so 8 divided by Nt is equal to 2 power 3. And then 8 over Nt is equal to 8. When you multiply by 8 and divide by 8, you get 8 over 8. And then Nt becomes 1 gram. Then when you look for the mass decayed after 24 days, this will be the original minus the Nt. Or original we had 8, then we subtract the 1 for the Nt, and then we remain with 8 grams. So in your process, it's 8 grams that decayed. So from 8 to 1, and the amount of grams decayed were 7. Now let's look at another way. How can we deal with it using the other alternative? If we use the alternative that we used in the table there, what can we get? Here we have the mass already given us, and the number of half, and then time. At first half, a half of 8 is 4. So 1 times 8 is 8. A half of 4 is 2. 2 times 8 is 60. A half of 2 is 1. Then 3 times 8 is 24. So at 24, the number of grams was 1. That means that after 24 days, the mass was 1 gram. And then like we did in the other example, the mass decayed after 24 days will still be 8 minus 1, which is equal to 7 grams. So in this case, you use the table and also you still get the same answers like you had in the first formula. Thank you very much for being attentive and listening and watching this video. I hope it becomes helpful to you.